Welcome to Batch ML Pipelines. We'll explore ETL and scheduled jobs for machine learning. Here's how it works. Extract, load, and then the scheduled jobs take over.
I'm the code architect, and I'm excited to explore Batch ML pipelines. We'll uncover ETL processes and scheduled jobs for efficient machine learning. Imagine building a fraud detection model. Every night, you need to train it with the previous day's transactions. This requires extracting data, transforming it into features, and loading it for training. We'll learn how to automate this process. Batch ML processes data in large chunks. Unlike real-time ML, ETL pipelines are crucial for preparing this data. Think of ETL as a data factory. Extract gathers raw data from databases, APIs, and logs. Transform cleans, filters, and enriches the data, creating features. Load moves the transformed data into a feature store or training dataset. Without this process, you'll be training models on dirty data. Let's dig into extraction. Connecting to multiple data sources is a challenge. You might have data in relational databases, NoSQL stores, and cloud storage. You need connectors to pull this data consistently. Consider using tools like Apache Kafka Connect or Airflow's data extraction operators. The key is to handle different data formats and schemas gracefully. Otherwise, you'll end up with data swamps. Transformation is where the magic happens. Involves cleaning data, handling missing values, and creating features. Imagine converting raw transaction data into features like transaction amount, location, and time of day. Use libraries like Pandas or Spark for efficient transformations. Data validation is crucial to ensure quality. If you skip this step, you'll be building models on biased data. Now let's explore asynchronous processing, vital for robust ETL pipelines. Message queues decouple pipeline stages, enhancing fault tolerance and scalability. This prevents bottlenecks. Imagine a sudden spike in data ingestion. Without a queue, the transformation stage could crash. Message queues like Kafka buffer these spikes. Consider using Apache Kafka for high-throughput data streams. For simple use cases, RabbitMQ might suffice. The key is isolating pipeline stages. Next, let's talk about caching layers. Caching frequently accessed data accelerates ETL. Think of it as a shortcut for repeated data lookups. To handle traffic surges, let's explore Envoy Proxy. It manages data flow and protects your pipelines. It's like a traffic controller. Envoy can route feature store queries, preventing overload during peak batch training windows. This ensures consistent performance during critical processes. Think of it as monitoring is vital for batch processes. Prometheus tracks job completion, training loss, and other metrics. It alerts on anomalies, preventing wasted resources. What about job failures? Implement circuit breakers to prevent cascading failures. If an API fails, halt the training to avoid corrupting long jobs. Circuit breakers enhance resilience, preventing failing jobs from corrupting long training runs. Let's discuss managing these scheduled batch jobs effectively. Consider using workflow orchestration tools such as Apache Airflow or Prefect to define, schedule, and monitor these ETL pipelines. These tools allow dependency management. These orchestrators offer features like retries, logging, and alerting, crucial for batch processing. They help manage complex dependencies between tasks. For more info, check out our Airflow video. Let's explore some best practices for optimizing ETL pipelines. Efficient data extraction and transformation are key to reducing processing time and resource consumption. Let's discuss scaling strategies for our ETL pipelines. As data volume grows, scaling becomes essential for maintaining performance. Consider distributed data processing frameworks. Frameworks like Apache Spark or Dask enable parallel processing across multiple nodes. This is crucial for handling large datasets efficiently, reducing processing time. Effective monitoring is essential for maintaining pipeline health. Implement robust logging and alerting to detect anomalies or failures promptly, preventing costly downtime. In summary, ETL pipelines and scheduled jobs are crucial for efficient data processing in machine learning. Optimizing and monitoring these pipelines will ensure reliable performance.
Like, share, and subscribe to my channel for more AI insights. I'm the Code Architect. See you soon.